So let us discuss a topic that is height and distance. Basically, this topic is application of trigonometry. So its use is something like this, that if you have a tower here, and then at a distance there is some person who is standing here. Now, two concepts. One is an angle of elevation. So what is the angle of elevation? As far as this person is concerned, and if this is the building, this is the lower portion, upper portion, and this angle is known as the angle of elevation. Now, with the help of this angle of elevation, we can find various parameters, for example, height of this building. Suppose this person who is having elevation theta as 45 degree, that's the angle of elevation. And suppose the distance, this distance is something like, let's say, 5 kilometers. Now, what will be the height of this particular building? So, this kind of a practical problems can be solved using trigonometry. Let's take this example only. Suppose the height is x. Now, this is x, this is 5 kilometer. According to trigonometric ratio, which is tan theta, x divided by 5 is equal to tan 45 degree. Because tan 45 degree is basically this angle of elevation, tan 45 degree is x divided by 5. Now what will be x? That is the height will be 5 tan 45 degree. Now tan 45 degree is 1, therefore x will be equal to 5. So that's how you can calculate the height by knowing the distance and the angle of elevation. Now there are various examples of various application of trigonometry using these things. Maybe if you know the height and if you want to find the distance, again you can use tan formula. If you know this particular length, then again you can use sin theta or cos theta. So various trigonometric ratios can be used to find height or distance of a particular building or tree or anything. Now there are certain identities, trigonometric identities. With the help of those identities, one can always find the solution of various problems. Those identities are like known as Pythagoras identities. And one of the identities is, say, sin square theta plus cos square theta is equal to 1. Therefore, one can replace cos theta or sin theta in a particular equation, or one can, suppose you know the value of sin theta and you want to know the value of cos theta. With the help of this Pythagoras identity, one can easily find all those values. That's the first one. Second one is 1 plus tan square theta is equal to secant square theta. That's another identity which is very useful and known as one of the Pythagorean identities. And the last one of these is 1 plus cot square theta is equal to cosec square theta. So using these identities, one can always calculate other trigonometric ratios if one knows about a particular ratio. So other ratios can easily be calculated. These are Pythagorean identities. There are various identities which are available so that you can solve various problems using these identities. Now, as you know that we have various measures of angle. One is that degrees, which is, you know, that it is a ray. This is my initial line. Now, anti-clockwise, if you calculate, then this is known as the degrees, right? Now, that's degrees. Now, radians, what is a radian? Radian is, suppose you have a unit circle. Unit circle means the radius of the circle is 1. Now, radius of the circle is 1. This is also 1. This is theta. Now, as far as this circle is concerned, Now, S is equal to R into theta. Therefore, S will be equal to, let's take this as theta, R is 1. So, S and theta will be same. So, 1 radian will be equal to, if I take S to be like this, then S, so theta is 1, suppose. So, radian will be, in fact, let's take it like this. Total length of this is 2 pi R. R I have taken as 1, so total will be 2 pi. So, what will be 2 pi radians? 2 pi radian will be equal to 360 degrees. Because as far as degree is concerned, this total angle is 360 degree. Therefore, pi will be equal to 180 degree. Now, this particular relationship will help you to convert an angle which is given in the degrees to radians, or an angle which is given in the terms of radians to degrees. Now, this conversion of degree to radian and radian to degree is almost in almost every question paper of SAT level 2, mathematics 2, you get a question like this. How to convert, that I am going to discuss, and of course with the help of this only. Now, what is 1 degree? According to this formula, 1 degree is equal to pi divided by 180. Now, this is now my formula for converting degree to radians. For example, what will be the radian conversion of 30 degree? I have an angle 30 degree. What will be the radian, equivalent radian? So, because 1 degree is pi by 180, so 30 degree will be pi by 180 into 30. So, that will be equal to pi by 6. So, if you convert 30 degree into radians, that will be pi by 6, right? Now, let's take another example where I have to convert radians into degrees. Okay. Now, pi is equal to 180 degree. Pi radian is equal to 180 degree. So, 1 radian will be equal to 180 by pi. Now, this is the formula which we can use to convert radian into degrees. For example, if you have say 5 pi by 6 is a radian, I have to convert it into degrees. So, what you do is 5 pi by 6 will be equivalent to 180 by pi into 5 pi by 6. Pi you can cancel with this, 6 will be 30. So, total will be 150 degree. Therefore, 5 pi by 6 is 150 degree. So, radians to degrees and degree to radians. So, you have to just recall, this pi by 1 degree is equivalent to pi by 180, or 1 radian is equal to 180 degree by pi, and that's all. That will give you all the answers of conversion from radian to degree or degree to radians. Now, let's come to another part of trigonometry. As a matter of fact, 2 formulas which are very useful in general, and in particular in the SAT level 2 mathematics 2, you almost get one of the formula at least in almost all the question papers. One is a law of sines, another is law of cosine. Now, with the help of law of sines, you can calculate various angles or sides of a particular triangle. So, if you have a triangle which is not a right angle triangle, now let me tell you that it is not a right angle triangle. Right angle triangle, there are various other trigonometric ratios. Now, here suppose my triangle is ABC, this side is A, this is B, this is small c. Now, suppose I know a particular angle, let's say this angle, and let's take, suppose this side is also given and this side is also given. I want to know what is angle A, what is angle C, right? Now, I can use law of sines. What is law of sine? Sine says sine A upon A, that is the angle A, sine of this divided by small a, is equal to sine B upon B is equal to sine C upon C. So, the information which is given to you, some two or three values, you can calculate the next other one. For example, sine A by A is equal to sine B by B. In this particular case, I know what is A, I know what is small b, I know what is angle B. So, what will be my formula now? I will not use this third part. What we can do is sine A divided by A is known, is equal to sine B, which is a known value, divided by B. I don't know what is A. So in order to find A angle, I'll find out sine A is equal to A upon B sine B. All the three quantities, that is A, B and an angle, capital B, is known, and therefore you can find A. Sine A will be some value, A will be sine inverse of that particular value. Then once you know A, what about C? Because sum of the angles of this triangle is 180 degree, and therefore it's easy to calculate C without using any formula. Once you know A and B, subtract from 180, sum of this A and B, you will get C. What about this small c? Small c also you can get by using these two. Therefore, once you know two or three values, in fact, proper values, by substituting in the law of sines, you can solve the triangle. That is, you can find all other angles which are unknown and other sides also. So that's the use of sine law of sines. Now you have law of cosines also, and that's quite interesting. Law of cosines is also another concept which is quite useful in order to solve a triangle. Sometimes when you have a triangle, let's take this, and here as far as law of sines is concerned and law of cosine is concerned, we are taking a general triangle, not a right angle triangle. So if I have this like A, B and C, this time there is small a, small b and a small c. Now if you know A, you know C and you know angle B also, suppose. Now in this case, sine law or law of sines will not help you in order to find other values, because you see this, you know A, you know C, you know this angle. So this, if you try to find out, if you try to use these formulas, you will see that you take first or second or first or third or second or third, only two values are known. Here, law of cosines will help you. And what is law of cosines? Law of cosines says that the side which you want to find out, B square, is equal to A square plus C square minus 2AC cos of B. Cos of B. Now here you see, you know A, you know C, you know B. The angle which is between these two sides. So you substitute in the right hand side, A square plus C square minus 2AC cos B, you will get B square, take the square root, that will give you B. So you can solve this kind of a triangle also with the help of law of cosines. Now once you know B, then you can, even in fact you can use after that law of sines also in order to find other values. So these two rules together, that is law of sines and law of cosines, can solve a large number of problems related with the trigonometry, related with the triangle which is not a right angle triangle. Now let's come to some other important formulas, that is double angle formulas. Sometimes what happens that we have something like, you know, suppose I ask you to find out the value of let's say 15 degree, sine of 15 degree or cosine of 15 degree. Now you already know sine 30, 45, 0, 60 and 90 degree. How to find 15 degree sine or cosine? Now here you see this double angle formula will help you. What is the double angle formula? Double angle formula is a formula which will convert a double angle into a single angle. For example, sine of 2A is equal to 2 sine A cos A. That's first. 2 sine A cos A. Another double angle formula is cos 2A is equal to 2 cos square A minus 1. Also, this is same as 1 minus 2 sine square A. And also same is equal to cos square A minus sine square A. So with the help of these double angles formulas, one can prove so many identities, trigonometric identities. Also, one can find angle 15 degree and all that by substituting A as 15 degree. So cos 30 degree, for example, cos 30 you already know, 1 plus cos 30 you already know, you can find cos square 15 degree. by dividing it by 2 and all that. So a simple calculation, a simple algebraic calculation will help you to calculate 15-degree or other angles. Now here you see that double angle formula is basically a half angle formula also. One can find out a by 2 also with the help of these formula. So basic formula of double angle are sin 2a and cos 2a. With the help of these formula, you can convert an argument which is like twice into a single argument which you can easily calculate. So that is actually all about the double angle formula.